A block of ice of mass capital M is at a melting point. A smaller mass M of water at a temperature of T degrees Celsius is placed on the top surface of the ice. The specific latent heat of fusion of ice is L and specific heat capacity of water is C. What mass of ice melts? First of all, the mass of the ice is much greater and its temperature is 0 degrees Celsius and it's at a melting point. And water is hotter and the heat will be transferred from the hot water to cold ice. And since the ice is a melting point, it becomes to melt. And all energy transferred from the water goes to melting of some amount of ice which is required, and definitely the equilibrium temperature will be at 0 degrees Celsius, because a small amount of water cannot melt a greater amount of ice completely, so that melted amount of ice becomes water at 0, and then it heats up to some equilibrium temperature which is greater than 0. So it's impossible because the mass of ice is much greater. So energy from water, it's mc delta T, so it's from capital T to 0, so delta T it's just capital T, and it goes to some amount of ice, let it be m ice, which is required, and this mass of ice melts completely. And to melt something, energy required is just the mass multiplied by the specific latent heat of fusion, so it's L. And we need this. So it becomes mc T over L. So it's A. And again, we don't consider total mass of ice. The energy from water is transferred into some amount of ice which melts completely, and all time temperature during melting temperature remains the same at melting point, so it's always 0 degrees Celsius. And that's all for this question.